Dilution examples that will hopefully make you more comfortable with it. Let's look at this example, and we can make it a little more flowery. Let's say a chemist needs 4.07 grams of glucose, but has a stock solution of 3.16 molar. How much of that does she need to pour out to get 4.07 grams? Think about it this way. Maybe it's a little more fun to think about it this way. Let's say you swallowed a poison and now you need an antidote. All right, and you need exactly 4.7 grams of this antidote. If you take more, you die. If you take less, you will die from the poison. So I want exactly 4.07 grams, and I have in some shaman gave me a 3.16 molar solution of that antidote. So I need to drink exactly the amount I need out of that to survive. And obviously, all of these things are fake, so it's just sugar water. So let's see how we would actually do that. Looking at the definition of molarity, molarity is defined as moles per liter of solution, right? Moles of solute divided by liters of solution. I'm looking for this, right? How much of this solution in volume will be the 4.07 grams. So I can solve for liters, and I get that the volume here, this is volume, is going to be equal to molarity divided by moles of solute. Okay, so I need the moles of solute. I have the molarity of the solution, that's that. So that would go here. I need the moles of solute, which we could get from this. We just have to convert this to moles. So let's convert that to moles. 4.07 grams of glucose, which is C6H12. So I'm going to call it glucose, big G. Okay. I'm going to use the periodic table to figure out my dimensional analysis factor here, which is grams per mole. I'm trying to get rid of grams and into moles of glucose. Okay, if you go look at the periodic table, C is 12, H is 1, O is 16. You add that all up, and it's 180.1 grams per 1 mole of glucose. You put that in, and you get that this is 2.26 times 10 to the minus 2 moles. So that thing, this value here, this will go here. That will go in there. This is moles per liters. This is moles, so I'll get liters. So that's great. So now, finally, my volume would be molarity is 3.16 moles per liter divided by this 2.26 times 10 to the minus 2 moles. And that is equal to 0.00715, well, 715 milliliters, liters, which the question didn't specifically ask you to get to milliliters, but just for fun, we'll do milliliters. That's just 7.15 milliliters. So but what this means then is that if you were to take 7.15 milliliters of this solution, you would get exactly 4.07 grams. So what I mean by that is, let me draw this out. Let's say someone gave me a vial here, and inside of it I have a solution of this sugar water or antidote of whatever you want, and this thing has a concentration of 3.16 molar. Okay, how much of this do I got to pour out into a second cup here, the one that I'm going to drink out of, right? I'm going to pour this out. How much should I take out to fill this? That's what the question asked me. I want this so that this here will be, what did I write? I forget. 4.07 grams. How much do I have to pour out to get 4.07 grams? Obviously, the concentration here is the same as the concentration here. I'm just pouring stuff out. That's all I'm doing. I'm not adding water. I'm not subtracting water, nothing. I'm just drinking a portion of this. So how much of this do I got to pour out? And we just calculated that to be 7.15 7.15 milliliters. If you pour 7.5 milliliter out of this, you'll get exactly 4.007 grams. That's the important thing, and believe it or not, comes up a lot. Understanding how to go from a stock solution, something that we have a lot of, and to get exactly an amount out. Okay, so that's one type of dealing with solutions, and sort of like, this is not a dilution, but it's sort of like within the same realm. Let's look at another example here. How am I going to prepare 250 milliliters of a 2.25 molar solution of potassium hydroxide if I start with 7.41 molar? Let's visualize that again. I like that. I think that's probably going to resonate with many of you. So I have in my possession here a solution of KOH. Okay, and this solution of KOH has a concentration of 7.41 molar. Meaning that for every liter of solution, I have 7.41 moles of KOH. Okay, that's what that means. Now, I want to make a second solution. Maybe I need that. And this solution here should be 2.25 molar. And not only that, I also tell you that this thing here has a volume of 250 milliliters. So I gave you that. Okay, so I want to create 250 milliliters of this concentration, and I have this concentration. Doesn't matter what necessarily it is. The KOH itself doesn't come into play. It's just the volume and the molarity that will come into play. So what governs this again is M1V1, which corresponds to that, is equal to M2V2, which corresponds to that, which, to remind you, M times V is equal to moles, right? So what I'm saying here is that moles of here is equal to moles here. I'm not changing the moles. I am just adding water. So how much water should I be adding or taking away to get this? Obviously, I'm going to add water to get less concentrated. So how much water do I need to add to get the 250 milliliters from this? That's the question, okay? So, all right, so let's do that. I know the concentration here is 7.41 molar. I don't know V1, that's what I'm looking for. I know the concentration here is 2.25 molar, and I know that the volume here is 250 milliliters. Notice that I didn't convert to liters because dimensionally it doesn't really matter. I can use any unit I want because it's the same. It's going to cancel. All right, it doesn't really matter as long as I'm consistent. But if you're unsure, convert to liters, just to be on the safe side. So if I solve for this thing, the volume that I get from this is 75.9 milliliters. Now, what the heck does this mean? This is what it means. This means that to make this, so let's go here. To make this, I'm going to erase this and draw this again. If I make this thing, I want 250 milliliters solution here. 2.25 molar. That's what I want. Okay. I want this to be a total of 250 milliliters. And so that means that the first portion of it here, this thing, the first portion, will be 75.9 milliliters of this solution. That's what that is. I need 75.9 milliliters of that, of solution number one, and the rest here should just be regular water. Okay, so I will take 75.9 milliliters of this. I will add enough water so that it's 250 milliliters, and then I'm done. Okay, so that means, just lastly, that 250 minus 75.9, that gives me 174.1 milliliters. So my recipe to making this thing is take 75.9 milliliter of the 7.41 molar solution and 174.1 milliliters of regular water. That will give me 2.25 molar solution. That's what that means. If you follow this M1V1 nonsense, that's what always happens. This is how you interpret the numbers that come out of this equation. Okay, how much of this to add to this to get this? I need. So hopefully this made sense. Let me know if you have any questions.